In this video is a selection of diagnostic questions from the best evidence in science teaching resources. I've chosen my favourite ones about solutions, and hopefully this will help you identify some of the common misconceptions that students have on this topic. So the first one is all about the classic dissolving of potassium permanganate experiment. And in this experiment, they call it a crystal of a purple substance. So I'm going to pause here and let you have a read of the question. So in the question, it explicitly states that the water is not stirred, and that might be something that you want to draw your students' attention to, because it allows you to identify the misconception that in order for dissolving to happen, then the person doing the experiment must stir it in order to get the particles moving, which of course is not correct. Okay, so the next one is more about particle diagrams. So again, I'm going to pause and let you have a read through. So students might choose option A here if they're thinking more on the macroscopic level. So they're thinking about what they observe, and perhaps they're thinking that the salt becomes a liquid and colourless like water. Students might choose option B if they think that the salt breaks up, but they're not thinking about it breaking into individual particles. This might be a more appropriate diagram for a suspension, although obviously in a suspension the fragments of solids contain a lot more particles than there are here. Students are likely to choose option D if they've just kind of mixed up the key of the particles here. Option C is obviously the correct answer. If students are having difficulties in translating from particle diagrams to what they observe in experiments or in real life, then it's our job to give them lots of opportunities to look at particle diagrams, to practice drawing particle diagrams for different situations. So, on to the next question. This is one that I've already used in class, and this is a good example of a question which you can get students to discuss. So, some of the best questions are best done by students individually, particularly the ones which sort of have an A and a B and a C and a D answer. This one is a really good one to get them discussing. So again, I'm going to pause and let you read it. So in this question, Omar gives the best answer, that the salt breaks into tiny pieces and mixes into the water. All the others show some kind of misconception. So Leanne here doesn't recognise that the salt is still present, and so she concludes that a new liquid has been formed. So we've gone from salt and water to a different type of liquid called salty water. And so she's not really thinking in terms of particles at all. Habiba recognises that mixing has occurred, but she explains it in terms of a salt turning into a liquid. So again, is using macroscopic properties to explain what she observes. And she thinks the salt must now be like the water. Jo has fallen into the trap of using the familiar word melting, because on the face of it, dissolving a substance looks very much like melting some substances, like ice, for example, melting into water. So he's missed the fact that melting is a completely different process at the particle level, and it's a change of state, and probably best to discuss with your students and really draw out these differences. Annabelle here correctly uses the macroscopic observation as evidence that the salt is still present, but can't explain those observations in terms of particles. She's trying to explain it, but still just using her macroscopic observation, so the salt has turned see-through. There's a lot of new vocabulary associated with solutions, and students find it difficult to use words like solvent and solute correctly. They often fall back on the simplification that a solute is the solid and the solvent is water, because that's the examples that they've used. This question looks like at a different example of forming a solution. It's using a marker pen and a white tile, and the marker pen is soluble in acetone and insoluble in water. And then, so you need to explain this to students, and then it gives them a series of options. So I'm going to pause here and let you have a read. So the correct answer is C, and to answer this question correctly, students need to realise that the marker pen is acting as the solute, and if it's soluble, then it will disappear. If it's insoluble, then it's going to remain on the white tile. Any problems with this understanding, and they're likely to choose A or D. They also need to realise that both water and acetone can be solvents, and that the marker pen ink might be soluble in one but not the other. So this would be a good question to do after they've learned about dissolving, just to check that they can apply their understanding to a really quite different situation. Okay, so this question here looks at misconceptions that suspensions are examples of solutions. So each test tube contains a substance in water, and which tubes contain a substance that is soluble. So students just need to look at the pictures and decide whether they're soluble or not. And this sort of understanding is really important when they come to doing chemical reactions later in Key Stage 3 and moving on to Key Stage 4, because if they're looking at, for example, A and thinking, well, that's a solution, that's soluble, then they're not going to understand things like precipitation reactions. So let's have a look at the possible misconceptions that are behind it. So if the student chooses option C here, then they're really just they're confused about the terms soluble and insoluble, and they've not really got them the right way around or straight in their minds. They probably need to see some more examples. This may also be the case if they choose A, but also if they choose A, they may be thinking that the suspension is a solution, and they'd probably be thinking that because it's not fallen to the bottom like it has in C. It is distributed throughout the liquid, but not at the particle level, so it's not a solution. It may be that all the examples they've seen in soluble substances have settled at the bottom like in C, and they've never seen an example like this before. So it is really important to use different types of examples of insoluble substances. Any student who does not select option D, so a student that looks at option D and thinks that's insoluble, is probably thinking that all solutions must turn colourless. And again, that's a useful misconception to overcome at this stage at Key Stage 3, because it will harm their understanding of experiments as they go on. So something that you can do, particularly about suspensions, is they could create their own. So they could take a powder, for example, by grinding chalk in a pestle and mortar, and then that will help them see that the tiny fine powders were once part of a bigger substance, and then they can form a solution and see the suspension for themselves. Okay, on to the last one. In our particles topic, we also take a brief look at solubility, and this question is really all about whether they understand what the word solubility really means, which often they don't. So I'm going to pause again and give you the chance to have a read. So a student who chooses A may have confused an increase in the amount of salt that dissolves with an increase in solubility. So as teachers, we then need to reinforce that solubility is a property of the substance itself, at a given temperature anyway. So the solubility of a substance cannot change when you add more water. You might dissolve more salt, but the solubility stays the same. Okay, so those are my favourite questions from the Best Evidence Science Teaching Resources all about solutions. There are lots and lots more questions available and lots of response activities. So these are things that you can do. Some of them are little experiments, some of them are discussions in response to identifying some of these misconceptions to help students move beyond them. You can find all of the resources at the website below, and I really would recommend that you go and have a look.